So number 1 asks, what's the general equation used to write the equation of a line when you know the line's slope and just a random point on the line? So this is called point slope form. And point slope form, you do y minus the y coordinate of your point equals the slope times x minus the x coordinate of your point. And so your m is here, your slope is here. Then you've got the y minus the y coordinate of your point, and you can call it y1. You can also call it k. And then you've got x minus the x coordinate, which again you can call x1 or you can call h. So a lot of times in this we call it hk. So it just means any point that is on your line. So that point is hk. So what do you know about the slopes of the lines if they are parallel? And that would be that they are the same slope. And for perpendicular lines, they're going to be opposite reciprocal slopes. So that means opposite sign plus or minus, and then the flip of the fraction. Number 3, the graph of y equals negative 4x plus 2 is translated by this rule. What is the slope of the translated line? Translated lines means it doesn't change the steepness of the line. It just moves it. So if this is our line, we're just going to be moving it down to the left 3 and up 2. So no matter where I translate this line to, the slope stays the same. So the slope is still going to be negative 4. Number 4, match each line with the perpendicular line. So let's make sure that we have the slope of each of these. So we see the slope here for part C is 2/3. But the others, we need to do a little bit of work to find them. So in part A, you subtract the y's. So 19 minus 4 goes on top. And then subtract the x's. So 9 minus 12 is negative 3. So this slope is negative 5 for part A. For part B, you would solve this and get it into slope-intercept form, which means solved for y. So we'll subtract 2x from both sides. So we get negative 5y equals negative 2x with a plus 10. Then we would divide everything by negative 5. And you'd get y equals negative over negative is a positive 2/5 x. And then 10 divided by negative 5 is negative 2. So this one has a slope of 2/5 for part B. So then let's take a look here. We can see in these that the slope here is 1/5. And we're matching to the perpendicular slope. So we want opposite reciprocals. So positive 1/5 is the reciprocal of negative 5. So this one goes with A. We can also see that number 3 has a slope of negative 2/5. Negative 5/2. So that's the reciprocal of positive 2/5. So this one is B. So that means this one must be C. And we could subtract these again. 4 minus 1 is 3. And then 1 minus 3 is negative 2. So that is the flip and the opposite of 2/3. Number 5, select all equations that are parallel to this line. And remember, parallel means same slope. So this slope here is negative 2/5. So we're looking for negative 2/5 as our slope. So positive 2/5 would not be good. Negative 2/5 is good. Negative 2/5 is good. And then positive 5/2 would not be good. And then we can solve this one. So we would be subtracting the 10x over, and then we'd be dividing by 5. So that's kind of a shortcut to subtract or do the opposite in front of the x divided by the number in front of the y. So this is going to give us a slope of negative 2. So E would not be parallel. Number 6, select all equations whose graphs are perpendicular to this. So this means the opposite and the reciprocal of negative 3/5. So the perpendicular slope to this would be positive 5/3. So we're looking for positive 5/3. So let's rule out a couple here. So this one's negative 3/5 for part B, so that's bad. This one's negative 5/3 for part C, so that's bad. Positive 5/3, that's what we want, so D is good. 10/3 for this one, so that's not right. Negative 3/5 for this one, so that's not right. So then let's look at part A. So we would subtract the 3x, and then we would end up dividing by negative 5. Negative over negative is positive 3/5, so that one's not good either. Number 7, write the equation of a line that passes through each of these. So let me just write out the general form of an equation again. So we have y minus our y coordinate equals our slope times x minus the x coordinate. Remembering that the slope goes here. We've got our y value of our point, and then we've got our x value of our point here. So write equation of a line that passes through this point. So our x coordinate is -1, so that's going to plug in here and be x plus 1. Our y coordinate is 2, so we're going to do y minus the 2. And then the slope is parallel to this one. So we want the same slope. So this one's slope is 3. -3. So we want to plug in -3. So then this would be the equation of our line. So if I just write that not in color, it'd be y minus 2 equals -3 times x plus 1. So same idea for this one. So we're going to have y minus the y coordinate equals the slope times x minus the x coordinate. And we want our equation to go through the point that is the origin. So our origin is our original point, and that's the point 0, 0. So then we're going to have y minus 0. We're going to have x minus 0. And then we just need the slope perpendicular to this one. So here's this slope. The perpendicular slope would be the opposite, so negative, and the flip of this, so -1/5 would go in here. And then if we just simplify this a little bit, it would just be y equals -1/5 x. Number 9, write the equation of a line parallel to this one and passes through this point. So I'll just write this out. Y minus the y coordinate equals the slope times x minus the x coordinate. Okay, our x coordinate is -6. So -6 turns that to a +6. Our y coordinate is 4. So it'll be y minus 4. And then we need parallel, so we need this same slope. And this slope is 2/3, so the parallel slope is also 2/3. So then that would be our equation. So y minus 4 equals 2/3 times x plus 6. Number 10, use the line shown to write these equations. So write the equation of the actual line. And so we can see this line crosses through the y-axis at 7. So we can use our slope-intercept form for this. And slope-intercept is y equals mx plus b, with b being the y-intercept. So this is our b, exactly where it crosses the y-axis. Then we just need to figure out our slope. And so then you want to find another point that it goes through and then just calculate the rise over the run. So this one is 1 and 2. And this one is going downward. So this is a slope of negative 1/2. So then we can write this equation is y equals negative 1/2 x and then plus 7. You can also, pick any point you want and put it into point slope form like we did on the last one as well. Then you want to write the equation of any line perpendicular to this one. So it doesn't matter what you choose. The only thing that will matter is the slope. So when you write your equation of your line, your slope needs to be the opposite reciprocal of negative 1/2. So for the perpendicular slope, the slope is going to be positive 2. And then for parallel, it needs to be negative 1/2. The rest of it doesn't matter. So you can write any equation you want. So long as this says 2x, and then it can be plus or minus anything else right here. And then for parallel, it needs to be y equals negative 1/2 x, and then anything else. So this could be y equals 2x plus 3. It could be plus 32. It could be minus 32. This could be minus 87. This could be plus 87. It could be 871. Okay, as long as the slope is 2, it's going to be perpendicular. And as long as the slope is negative 1/2, it's going to be parallel. All right, then finally we have parabola practice for this next part. So in general, what is the equation used for a parabola using the focus and the directrix? So we have y minus the directrix squared. Okay, and so then this is going to be your directrix. And then the focus is an ordered pair. So the directrix is a line. The focus is a point. So I'm just going to call this x of the focus and y of the focus. Actually, let me switch colors here. So y of the focus and x of the focus. And so then we have y minus the directrix squared equals x minus the x coordinate of the focus squared plus y minus the y coordinate of the focus squared. So this will be the x of the focus and this will be the y of the focus. So write the equation that states xy is the same distance from 0, 5 as it is from this line. And that's the definition of a parabola. So a parabola is the set of all points that are equidistant from some directrix and focus. And so what this is asking us to do is write the equation of the line with this focus and this directrix. So we're going to do y minus the directrix squared, and the directrix is this negative 3, so we'll plug in negative 3, and then that will equal x minus the x coordinate of our focus plus y minus the y coordinate of our focus. And the x coordinate of our focus is 0, and the y coordinate of our focus is 5, so y minus 5, so then that would be our equation. And then similar thing for this next one, except for now it's just telling us that the directrix is the x-axis. So you need to know that that means that the y coordinate is 0. So on the x-axis, the y coordinate is 0. So we'll take and we'll do y minus the directrix, which in this case is 0. And then x minus the x coordinate of the focus plus y minus the y coordinate of the focus. X coordinate of the focus is 4, so just x minus 4. And then y coordinate of the focus is negative 3, so negative 3 we would plug in there. Number 4, a parabola has a focus of 3, negative 2, and a directrix of y equals 2. the point a negative 8 is on the parabola, how far is the point from the focus? So for this one, I'm just going to sketch this out so we can, so we can look at this. So we've got the point 3, negative 2 here. And then the directrix is at y equals 2. So that's going to be here. And then we have this point something negative 8. Okay, so we don't know what the a value is. It doesn't really matter. But we do know that the y value here is at negative 8. So this down here, this point is on this line somewhere at negative 8. So how far is the point from the focus? How far is this point from the focus? And it is on our parabola. So that means that we've got this parabola that goes through here, right? And the point a negative 8 is on here somewhere. And this orange parabola is the same distance from the directrix and the focus. Okay, so any point on here is the same distance from the focus as it is from the directrix. So let's just say our point is here, a negative 8. The distance here, okay, this distance is equal to this distance. And we know negative 8 up to 2 is a distance of 10. Okay, so negative 8 to 2, those are 10 apart. So then we know that this point is 10 away from here as well. So the point is 10 away from the directrix, so it's 10 away from the focus. Number 5, write the equation for the parabola with each of the given features. So this first one gives us the focus and then says the directrix is the x-axis. Remember, that's saying y equals 0. So we'll do y minus the directrix squared equals x minus the x-coordinate squared plus y minus the y-coordinate squared. And that's going to happen for each of these. So let me just copy this down here. And then we've got in this first one, the focus given to us. So we've got this 0.52, and in this next one, we have the point negative 23. Let me just get these colors on here. And then we've got 0.7 for that last one. And then in this next one, we had the directrix given to us in each of these next ones. Okay, so then let's plug our stuff in. So we do y minus the directrix. So in this case, that's going to be y minus 0. And then x minus the x-coordinate, which is 5. So y minus 5. Or sorry, x minus 5. And then y minus the y-coordinate, which is 2. Next one, again, y minus the y-coordinate of the directrix. So y minus 7. Then we'll do x minus negative 2. That was the x-coordinate of the focus. And then y minus 3, the y-coordinate. For this last one, y minus negative 1. And then x minus 0. And y minus 7. Number 6, a parabola has a focus of negative 1, 6 and a directrix of y equals 4. Determine whether each point below is on the parabola. Explain your reasoning. So you can write out the equation here and plug these in if you would like to. You can also kind of look at how far the point is from the focus, if it's nice, and see if that's the same distance from the vertex, from the directrix. I'm just going to write out the equation here. So y minus the directrix, so y minus 4 squared should equal x minus the x coordinate, so x plus 1 squared, and then plus y minus the y coordinate, so y minus 6 squared. So these two things should be equal. So when we subtract or when we do x plus 1 and y minus 6 squared, okay, that should equal the y coordinate minus 4 squared. So let's just plug these in here. So we're going to be doing the y coordinate, which is 5, minus 4 squared. That should equal the x coordinate, negative 1 plus 1 squared, and then plus, the y coordinate, which is 5, minus 6 squared. So 5 minus 4 is 1. So we've got 1 squared, and that should equal negative 1 plus 1 is 0. So 0 squared. And 5 minus 6 is negative 1 squared. So this says 1 equals 1. So this one is good. And then we're just going to do this for the rest of them. So we're going to take the y coordinate minus 4 squared, the x plus 1. So we're just plugging these in to the equation up above and seeing if they work out. So our y coordinate is 7. So 7 minus 4. And then our x coordinate is 1. So we're doing x plus 1 squared, and then y minus 6, and the y was 7. And then we're just seeing if these equal. So 7 minus 4 is 3 squared. 1 plus 1 is 2, so we'll do 2 squared. And then 7 minus 6 is 1 squared. So we have 9 equals 4 plus 1, and that is false. So this is for number 2. So that was false, so that didn't work. So then we'll plug in for this next one. So we'll plug in the y coordinate, which is 9. And then the x coordinate, which is 3 plus 1. And then the y coordinate, 9 minus 6. So 9 minus 4 is 5. 3 plus 1 is 4. 9 minus 6 is 3. So we get 25, and then we have 16 plus 9, and 16 plus 9 is 25. So C is also on the parabola. All right, so in this last one, we're just going to do equation practice, or we're just going to practice with the equations and deciding if the point 2, negative 3 is on the graph of each of these. So this one's in point slope form. So you might notice that this is the ordered pair. Okay, so x minus 2. So the 2 is your x and 3 would be your y. So 2, 3 would be on there. And as a line, that means 2, negative 3 cannot be on there. You can also plug it in. So you could plug in 3 in for y and 2 in for x. 3 minus 3 is 0. Negative 3 in. So negative 3 minus 3 is negative 6. All right, in this last one, we're going to be working with all the types of equations and just trying to see what we know. So this one is select all equations for which this point is on the graph. Now, there's going to be different ways you can do this. One of them is to just plug this in for x and this in for y into all of them. If both sides of the equations are equal, then the point is on the equation. You may also notice some, like in part A, that this is in point slope form. So that means that one of the points on this graph is the point 2, because that's what we're subtracting from the x, and then 3. So 2, 3 is on this line. If 2, 3 is on the line, 2, negative 3 cannot be, because then it wouldn't be a line. So you might notice that. Okay, then the other thing, like I said, again, you can just plug these in. So you could do negative 3 minus 3 and 2 minus 2. Negative 3 minus 3 is negative 6. 2 minus 2 is 0, and see that those don't equal. Part B, we would plug them in. So we'd be doing 4 times 2, which is 8, and then plus negative 3, so minus 3 or plus negative 3. 8 minus 3 is 5, so we get 5 equals 5, so this is on this line. Y is negative 3, x is 2, so we have negative 3 equals 5 times 2, which is 10, minus 13. So we have negative 3 equals negative 3. That means that point is on the equation. Part D is a circle centered at 0, 0. So we can just plug this in. So 2 squared is 4. Negative 3 squared is positive 9. 4 plus 9 is 13. So 13 equals 13. That is on our circle. Part E, we see as a circle equation, and we see that the center of this one is 2, negative 3. So that's the center is the point we're looking at. So that one's definitely not going to be on there because that's going to be in the center of our circle. Whoops. So 2, negative 3. So this point would be set in the center of this circle. So definitely not going to be on it. You can also plug it in. 2 minus 2 would be 0. Negative 3 minus a negative 3 would be 0 also. So you get 0 plus 0 does not equal 25. Then next one, this one's a parabola. So we could plug it in here. So plug in negative 3 for y. So negative 3 equals, and then 2 minus 2 is 0 squared plus 3. So we're getting negative 3 equals 3. So that's not on there. And then the final one, negative 3 equals 2 squared, which is 4 minus 7. And 4 minus 7 is negative 3. So that one is on that parabola.